Okay, let's. Okay, we've got other languages to consider, not German and Spanish and things. This is JavaScript language. Okay. Arrays. Arrays are lists of objects. Or lists of things, not just, well, objects. Of course, everything is an object. It's a list of things. And there are two kind of flavors. There's ordered lists and kind of named lists, which are also called associative arrays. So an empty list, lists are declared with the square brackets. And to declare an empty list, I can just go var empty equals 2 square brackets with nothing inside it. But if I want to declare a list with something in it, I just comma separate the values that I want in my list. So here's a list called primes with the values 2, 3, 5, 7, and 11 in that list. An array can be made up of lots of different things. It can be a miscellaneous array. It doesn't have to be an array of all numbers or all words. So here we've got a miscellaneous array in which the first value is 3.4. The second value is a Boolean true. The third value is a string by hat. And there's a fourth value, which is a null. So there's in fact 4 values in that string, in that array. If I want to get out of those values, I just use the index of the item in the array, just like the index of the character in a string. So if I want the first object, it's object 0. That would return me 3.4. If I want the third object, index 2, I get my hat. If I want to add another item on in a numbered position, I just do miscellaneous and then the new number of the item and then equals the value that I want to put in. So if I wanted to change the value of the first item, it would miss 0 equals a value, and that would just change that value, that item on the array. Here I'm adding the fourth value, so remember that 0, 1, 2, 3, so 4. I'm adding another value on the end, and that would be given the value another. Now if I'd have put that as say 6, I think what would have happened if another would have been put in position 6, and then they would have inserted 2 null values to fill up the array to make it full. Again, I can use just with a character string, I can use the length argument to get the number of items in my array. And once I've got the number of items in my array, I can loop through it and do things like that. We'll see looping in a minute. It's quite common that you don't actually need to care about the index of values. You just want to add another value to your list, or take one off your list. So it's as common or more common to use these push, shift, and pop functions or methods to populate an array as it is to actually use the indexes on the array. So here I've got an array, fruits, banana, orange, apple, mango. If I want to add a new item, I can use the push method on the variable to add myself a kiwi. And then I've now got a list with, it shouldn't be, that should be, it should have mango kiwi, sorry. Oh God, another typo error. Mango kiwi. Shift removes the first item. So in this case, we've removed banana, the first item. Pop removes the last item. So in this case, given I made the mistake, I removed kiwi, and kiwi gets removed. So push, pop, and shift. Associative arrays are arrays in which the items are identified by a key rather than a numeric value. So I can create an empty number called an empty array called place, and then I can put a value, an item with a key name equal to London. So then when I search for, if I want place name, that would return me London, yep. And then if I want to add a latitude, I can add a latitude. And if I want a longitude, can add a longitude. So these are the named values. Instead of an index, it's a named key to the array. Okay, so here's an example here in JS Fiddle. Place, in fact, that's the example. I've got place name is equal to London. There's my latitudes, there my longitude. Now I've got an alert box that gets the name item from place, adds some text, lat, gets the lat value from place, add some text, and then the long value from place, turn it in a alert box, and I've got London, latitude, whatever, longitude, whatever. You can do multi-dimensional arrays, so if you wanted to store a grid as an array, and it wouldn't recommend that, there's probably better data types for storing grids in, but there probably are, I've never done it, but here I can create an array of arrays, and it's a two-dimensional array, and then I could say the first value, or the first value in the first list and the first value in the second list, I'd put to 1, 1. The first value in the first list and the first value in the second list, I've set to 2, 1. Yep. So you could make a two-dimensional array, you could make a three-dimensional, four-dimensional array for storing values in like that. Chances are you won't need to do that in this course. If we want to compare values, we use the various comparison operators, just like we did in SQL, which return true or false. So here I've got a var x, var y, and we can use the double equals sign to test if variables store the same values. So in this case, x is equal to y, they store the same value, therefore true is returned. But if the pling, the exclamation mark equals means not equal to, just like it did, I think did we have a not in? Yeah, we do support not in SQL. I have these problems that I try and remember what's supported in SQL, what's supported in Python, what's supported in this, and it's very difficult to remember them all. There is another operator for equality, which is equals, 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 which is a more strict test. So it's saying things like, is this exactly the same type of object? Don't worry about that, just know it exists, that there's this additional test. Okay, we use these conditional tests most often because that's how we control programming flow through conditional statements, which test whether something is true or not and branch the code depending on which criteria are met. So JavaScript supports an if else statement for branching code. So here, if, and then in the curly brackets we have our condition. If our variable time has a value of less than 12, we're going to say we're going to set our variable called greeting to equal good morning. If, however, else if the table time is less than 20, I'm going to say g'day. But if it's 20 or greater, if it's anything else but the criteria that we have here, then I'm going to say good evening. So, and the code that's fired in this if else statement is the one that is met first that is true. So if we had the value 15, we would look at this condition, no, that's not met. We go to the next one, yes, it's met, then this section block of code fires. We ignore this. So if 2, because a value of 15, well, no, yeah, so just that one fires. It also supports what's called a switch statement, which is a sort of different form of writing an else if. So for example here, if we wanted another condition, we would have another else if statement. And we'd have so we could add in more and more else if statements but it's a rather ugly syntax. It's all right with 2 or maybe 3 options, but once you get to 5, 6, 7 options, it's not a very nice syntax. This is a better syntax for that kind of thing, and it's called a switch statement. And what it does is it takes a value. It takes a value at the top here, and in this case, it's just getting the day. It's using the date object, the internal date object, to get the day of the week from the computer. Okay, so it's getting me a day of the week, and it's going to return an integer between 0 and 6, depending on what day of the week it is. And then in the switch statement itself, we have case statements. So we say case 1, so that's the first index 0 of the days of the week, which is Sunday, and I'm going to set my variable to day to Sunday. Note the break command we need in here that says we're going to stop that at this point. So we need a break command in there. If it's 1, then we set it to Monday, etc., etc. It's just a neater syntax for doing the same thing when you've got quite a few options to code. So that's conditional statements. The other major programming control statements, along with conditional statements, which determine branching of the code. If this condition, then do that. Otherwise, do something else. Is loops, and loops are to do with iterating, doing things multiple times until some kind of condition is met, some criteria is reached. And JavaScript can support several of them: a for loop, a for in loop, a while loop, and a do while loop. So a for loop simply works like this. So for, we have I don't know what the correct word for that is, but it's a counter variable. In this case, it's called I. I is the normal. There's a standard sort of a standard way of doing things, or a sort of community-based sort of way of doing things, which is when you've got something that's used as a counter. So you're iterating a counter or something. You often, the first variable, if you want one counter, you call it I. If you want a second counter, you often call it J, then K, then L, then M, then N, then O, then P. It's just an unwritten convention. But it's really helpful because the moment you see I in a code, any bit of code, you know it's being used as a counter, which is a really handy kind of one of these shortcuts for reading people's code. So for I equals 0, so we start at 0, semicolon, until I is less than 5. On each iteration, we're going to increment I by 1. So this is the increment, this is the starting value, and this is the value that you're testing for on each for loop. And then I've got some code in here that takes the text variable. The plus and equals means take the value that's in my text variable, in this variable, and then add this to that, concatenate this string, in this case it's a string, concatenate this string into this text. And we're going to print, we're going to print to the screen. I think there's something wrong with my code here actually, when text is displayed, in the text is displayed. So each time, so we loop through this 4 times, or 5 times. First time the value is 0, and we output the number is 0. Second time the value is 1, through 3, 4. And when I gets to 5, this criteria is broken because 5 is less than 5. 5 is more than, it's not less than or equals to, it's less than. So when the value is 5, the loop stops and the code continues further from the loop. If we want to loop over an array, we can use the for in syntax. So I've got an array here of people, Joe, Kyle, and Lawrence. I can set a variable. So I've got a variable text. Basically, I want to turn that into a text list, comma-separated text list. So that's what I'm going to save all my answers into. And var x, in this case, I'm just using it as a marker for each iteration. So for x in person, so we're looping through person, and each time we loop through, we're going to move from up the list of items in our array. So for x in person, what we're doing is adding the text in for x in person. So x is incrementing. So x, so person x, the first time we go 1, it's person 0. So we add person 0 name onto the into text. The second time we pick up Kyle, and Kyle gets concatenated. We get comma, space, and then we have Kyle. And then the third time we go through, we pick up X is Lawrence, or X is the position, position 2, the value of which is Lawrence. So that gets concatenated on there. And then what we actually get is, not quite sure what this line is doing in there, but what we end up with is Joe, a string that says Joe, comma, space Kyle, comma, space Lawrence. So if we want to get the values out of an array and into a CSV file, effectively this is what we do. Then we have to write this line to a text file to output that. Not quite sure. Why have we got this text.text substring text length -2, 2? I tell you why. I'll tell you why. Because the second time, the last time the loop runs round, I've added on a comma and a space onto the end of Lawrence, because each loop adds the name and then a comma, then a space. But because once I've finished my list, I've got a comma and space after Lawrence, and then I want to remove that. So I've done a substring to remove that text and that last comma and space off my string. That's what that line is doing. While loops, So while loops test for a value, and when a value is found, then the loop stops. So in this case, we've got var cars, a list of cars. We start with I equals 0, and we set an empty string called text. And while cars I, so while I, the ith index of cars, is returning a valid value, it's not returning a null, which it will do once it gets beyond 4, it will return a null. So while I've got a valid value in cars, I'm going to add cars, the value of cars in the ith value of cars to my text element. And then within the while loop, I increment by 1. So the next time the loop starts, I is now 1, gets Volvo. So it adds Volvo to our text and a BR for a carriage return on an HTML page. I gets increased to 2, come through the loop again, and I get Saab. Do while has a while function at the end. So we can set our counter to equal 0, and then we're going to do this text, do this function, this block of text, while I is less than 10. So in this case, we're going to loop through that code 10 times. That's all of the main functionality that I really want to tell you about JavaScript. As I say, to learn these loops and everything, you've got to program them. That's the best way to learn. We do have to, however, learn a little bit more about function and objects, just a little bit more to get us going. So first of all, functions. So remember, we didn't go into functions in Postgres because there was just no need. It was just a sort of level of complexity beyond which we needed to go to. But the idea of a function is that if you're doing something multiple times, why not write a little bit of code that does that function? Then you've only written the code once to do the job, but you can call that function many times whenever you need to do that job. Simple as that. So they encapsulate some kind of functionality. Why do you want to do that? Well, one of the main reasons is the reuse of code. If I'm doing some kind of search, and I'm doing that search from multiple different places in my code, I can have a function that does the search, and every time I want to do the search, I call the function and it runs the code to do the search and returns me the results from the search, rather than having versions of that search code throughout my code every time I needed to do that search. So it means you can reuse code, which reduces your code base considerably because you're calling a function one version of the code rather than having multiple versions stretched throughout your code. And the other thing, so that reduces code file length. But the other thing is sometimes you use functions simply to partition functionality in your code so that your code files aren't humongously long. So basically, if you have a program that says do this, do A, do B, do C, do E, do F, do G, you could write the whole thing of what A, B, C, D, and E are as sections of code, but you might end up with 1,000 lines of code in one file, which starts to become difficult just to scroll up and down. If you're scrolling up from the top of the file to the bottom of the file every few minutes, and it's 1,000 or 10,000 lines, that's pretty slow. But if your first line, your do A, just says call function that does A, then you have one file for function A, and everything's in function A, and you can look at that. And then you do function B, and you call function B. So it's also can be used as just a way of helping you organize long bits of code into smaller files and things. How do you define functions? Functions are just defined with a function keyword. You give it the name of the function, and then you can, this is an anonymous function. Oh, dear me. All right, so this is probably a poor use. So you could have a function, it should probably have a name there, and then some kind of code inside it. And in this case, oh dear, that's a wrong function. Defined as function, it should be function myAlertBox A in brackets. Sorry, and then you pass in A, and A gets displayed in this case. We call this function with myAlertBox H. That's a lousy thing. I've got a better example here, as in the definition of functions. So functions are how we define objects. Objects, you remember, contain properties and methods. Okay, so this is a better example of the use of a function, and in this case, it's defining, in this case, an object. Okay, so function is the name of the function. The function is called myPerson. We pass in 3 variables into myPerson arguments. We can pass in 3 arguments, one called first name, one called second name, and one called age. Okay, pass in 3 arguments. Within this function, which defines an object, a JavaScript object, there are 4 lines of code. Note the object itself is defined within these curly brackets. The first line says this dot first name equals first name. Now within a function that defines an object, this means the instance of the object that we're talking about. So this is a class definition. We'll see the object being used in a moment. So this refers to, if I've created a person, then this refers to the person who has been created. So what it's doing is saying set the value of this instance of the myPerson object to the first name passed in. Send the last name property to the value of last name passed in, and set the age property to the value passed in from age. And this dot details, this property called details, I'm setting to a variable called ret details. We'll see that on the next page. And ret details is a function, and the function with a function that's a property of an object is a method. Right. So it's getting hard now. Appreciate this. So here's my function ret details for return details. It's having no arguments input into it. And what's it doing? It's returning. It returns the value out of the function when the function's called. This is what it returns. The first name plus a space plus the second last name plus a string for age plus the age. And so it's going to return a string that's a concatenation of the 3 values of the fields. If I want to create a person, an instance, I can do var test person, this is my example person, is a new instance, new keyword, of my person. So it's a new my person object. And I'm passing in 3 values, John, Doe, and 45. First name, last name, and age. So here we are in JS Fiddle. So I define my object of type my person. I then define my object method, retDetails, to return the details of that person. I create an instance of the object of type my person called test person. So I've created a variable called test person, which is a new my person, pass in John, Doe, and 45. And then I can run an alert. I've just got an alert box that returns me person is, and then test person, and then I'm calling the method retDetails, which we know returns the string that concatenates the values of the fields together. And that's what I get. Why am I using window.alert as opposed to alert? It was just that the code that I happened to, snippet that I had to find online, used window.alert, which is just a sort of a fuller path to the alert box than I've been using. So this Windows dot is just extraneous. It's not needed, but it does no harm to include. And there we go. Person is John Doe, age 45. Right. So I think that's all I've got to say on JavaScript, pretty much. As I say, you'll experience it, you'll learn it. Now, when you want to write a program, initially you'll just be writing simple scripts that are just a sort of line, a single line of code, or a single page of code, a section of code. You may need to write a few functions for you will need to write a few functions probably for your assignment. But that's about as complex as we're likely to go. But if some of the more advanced applications that you might build might require several different JavaScript files. That's about as far as you're likely to go. I'll talk about the assessment I've decided next week rather than this week, because I wasn't quite ready this week to talk about it. Okay, so how do you go? Just like when you're designing a database, when you're going to write a program, it's a good idea to design the program, just like you design your database before you actually go and build it. It's a very sensible thing. What is this program going to do? What's its flow going to be? How's it going to operate? And as I've said, program flow is defined using these loops and conditional clauses. That's how you decide what the flow of the program is going to be. And it's generally a good idea to develop a logical design that specifies overall how the program's going to operate without any reference to any specific software before you actually start coding. And there are two approaches to program logical design, because this is equivalent to logical design, EL modeling in database design. We can use flow diagrams, and pseudocode are the basic ways of doing it. And both share that they use natural language. They also have ad hoc notation, so nothing, while there probably are specific notations for UML for drawing flow diagrams of programs, it's not most people don't bother with that. Okay, so there are lots of different ways to make T. And making T is a program. You're doing things. It's a set sequence of actions. So, for example, a program, if we wanted to represent the program required to make a cup of tea as a flow diagram, we might draw it up like something like this. Lift the kettle, approach the sink, place the kettle below the tap, blah, blah, blah. Turn on the tap. Turn off tap when full. Okay? If it's not full, then you keep, I don't know, do you keep turning on the tap, or what do you do? It looks like you keep turning on the tap. You don't turn the tap off. Okay, so you keep turn the tap off. So when it's full, we plug in the kettle. Then we place the tea in the teapot. Oh, that's interesting. I haven't made tea in a teapot for many years. Then has the kettle boiled? No, wait for the kettle to boil. Once it's boiled, yes. We pour the tea into the teapot. Tea brewed? No. Keep monitoring the tea until it's brewed. Yes. Pour tea, add milk, drink. Now, hopefully we could give that to just about anyone and they might manage to make a cup of tea, even though they've never made a cup of tea in their life. But hopefully there's enough information and it's coherently described that you really couldn't go very wrong with that. It's a logical description of the process of making tea. The alternative is that we could write a pseudocode program for how we make tea. And pseudocode is basically writing things like you would write a program, but using sort of natural language rather than the particular keywords and constructs and clauses of any particular language. So we could take this sort of English language program and then turn it into a computer program in Python or in JavaScript or whatever programming language. So here's our program, make a cup of tea, organize everything together. Plug in the kettle, put tea bag in cup. Oh, different. So this is a different program for doing the same thing. So there are multiple programs that can do the same thing. While kettle is not full, do keep filling the kettle. End while loop. Wait for the kettle to boil, add water to the cup, remove tea bag with spoon, fork, add milk. If sugar is required, then add sugar, else do nothing. End of serve. End. Okay, so you get the gist. Both these methods, the flow diagram and the pseudocode, both describe an unambiguous flow of processing, or at least reasonably unambiguous. So hopefully you could pass that on to anyone, programmer, and they would make you a cup of tea. You get a slightly different cup of tea with each recipe. So maybe you'd have to think carefully about which is the best way of getting to the same end point, a cup of tea. So that's pseudocode and flow diagrams for logical modeling. That's really all I've got to say on it. When you start writing your application, it's a good idea to try and draw either a flow diagram or write some pseudocode for how you intend your application to work. Debugging. You will probably spend more time debugging than you will spend programming. Be prepared for it. It's the major job. It's probably the bigger job than the actual writing of the code itself. Well, it is writing the code itself. If the code doesn't work, the code doesn't. It's no good. It's no good code. Debugging is an art. I'm still learning how to debug. How do I do it? Alert boxes. I want to know the value of a variable. I can use an alert box. I can do the console log and look at the inspect, and I can output the value and see what values I've got at various times in my code and find out, eventually I'll find out that this value is in fact a string, whereas it should be an integer or something like that. Or that I've not failed to add all my elements to the right array. So use alert boxes, use console log to look at the values of. You can also write out actually onto HTML pages, but generally I wouldn't bother with that. That's another alternative. You could actually write to the document, and you'll see that in practical. If a line of code, if I've written, say, 20 lines of code, and something's not working, and I'm not quite sure what's gone wrong, I sort of start at the end, and I start commenting lines out until it does actually work up to that point, and then I know, then I start uncomment the next line, the line that's not doing what I think not producing what I'm hoping it was produced, and I'll look at that line, fix that line, then move on to the next one. So basically comment out code back until you know where you are, and then slowly move forward uncommenting lines, seeing what the values are and finding out where the error lies in your code. You can, and of course, you can do that using the Firefox Chrome identity interfaces. They're a good place to look at that kind of stuff. Obviously, search the web for examples of code. It's easy to just slightly use the wrong syntax, use some curly brackets instead of some square brackets to miss out a comma, everything like that. So do check the web for examples of things that you're trying to do, code examples for what you're trying to do. There's loads out there. Look at the help files. Help files for computer code, if you look at Postgres help, everything is there, but it's perhaps not the most accessible language. So do use the online help, the official help files for JavaScript and things like that, but you may well find blogs and things like that more informative and more friendly than the actual description of the various code aspects of the code keywords and the variables and things like that. Also, of course, make sure that when you're looking for answers that you're actually in the right version of the software. So JavaScript is now, I don't know what version of JavaScript we are, but whenever you're doing anything with computing, always be aware that versions change through time. The examples online may be from 10 years ago from a previous version of the software, or indeed they may be for a more up-to-date beta release, a really recent release, whereas you're using software from several years ago. So make sure you're at the right version, because things vary between versions. Just talk among yourselves, as you've been quite good in the database side of things. Do talk to each other, post on the Facebook page, send me an email, send me your code. If you want me to solve a code problem, I need the code, otherwise I can't solve it. It's amazing how many people email me and say, I've got a problem, can you help? This is a line description of the problem and no code. And I would think this probably is almost the most important one of all. Go and have a cup of tea and sleep on it. I can't think how many times I've banged my head the night before when I'm tired and I've been coding for 3 or 4 hours or something, or all day. It's the end of the day, I want to get something finished, and I've spent an hour and a half trying to solve this last little bit, then I've gone to sleep, I've woken up in the morning, and within 10 minutes it's solved. So do sleep on it is probably the best advice I could probably give you. All right, the document object model, we'll probably do this quickly and then I'll probably leave the PHP for next week. So the document object model, the DOM. The DOM, it sounds like something from a mafia family, and yes, we have to look up to the DOM, look up. Okay, so what is the DOM? The DOM is a W3C, and then the W3C are the organization that run the standards for the World Wide Web. It's a standard for interacting and representing HTML and XML documents. Basically, it's a hierarchical tree model of a document page. And we can edit and update the document object model, adding new elements to the document, changing the values of elements, etc., etc. And the document object model, and indeed JavaScript itself as it presently exists, were the product or came about after what's called the late 1990s browser wars, which maybe predate you a little bit, but basically it was when Microsoft Explorer sort of first came on the line. It did things differently to the existing browsers, Netscape, and things like that. So there was an attempt by Microsoft to sort of get the internet community using Microsoft Explorer and not using other people's browsers. That failed, and everybody came together, and WC3 shook hands and decided on the standards that we presently use today. So basically, we know the HTML document is a hierarchical document, and the DOM model is just a hierarchical tree way of accessing the elements in a document. So we can go from the document to the root HTML element, and then under there we can access the head element or the body element under the HTML tag. Then within the head tag, there's maybe a title tag that we can then access, and then within the title tag, there's some text associated with that title, and we can access the text in the title. In the element here, we've got a header element, H1, which contains the text, my header. We've also got an anchor element, which perhaps contains the inner HTML, my link, and has an attribute, href. So it allows us to get hold of these objects in the document. So we can get access to the document model, DOM, in JavaScript simply by using the keyword document, and that describes the HTML page in your browser. And then the document objects have methods that allow you to find and change the values of the elements within the DOM, the document object model. So there are methods like document get element by ID. Now, if you remember, the ID attribute of an element should be unique within every page, so there should only ever be one value, one element in a page with the same ID. So we can just search by the ID string, and that should return us one element. That will return us one element with that ID. Tag names can be, elements can have name tags, and those name tags can be repeated across multiple elements. So in that case, if you want to get all the elements, an array of elements that share the same tag name, for example, all the paragraphs, we could get all the paragraph elements in an array by using elements by tag name. Class, you may have come across class. Elements can also have a class, particularly used for CSS rendering. So if I wanted all the elements with the same class, then I can get an array of them by using that method. And then there's a whole set of other methods here that allow you to change the value. So to change the inner HTML, the bit that's between two tags, is the element.innerHTML method. We can set the values of attributes, etc., etc. There's a lot of these methods. We don't need to know any of the detailed ones. Is there any more on there we need to particularly highlight? The click event. We will be using that a lot because when you click on a button, that fires when the button is clicked. So the on-click event is an event that fires when the object on the page, the HTML page element, is clicked on. So in JavaScript, manipulating the document object model. So, for example, I've got a HTML. I mean, I've cut some of the page down here. So I've got a paragraph with the paragraph has the ID element set to demo. ID, remember, has to be unique across all elements in the page. And then I've got a script. So basically this empty paragraph will be created. Immediately after the paragraph is created, a script runs. The script looks for the element with the ID demo, finds this paragraph, and then will set the inner HTML, the text between the two P, the start and end tag, to equal hello world. And then there we go. When we run that, there's it in JS Fizzle. Hello world gets written within that paragraph. We've updated our page. Okay, let's leave PHP for next week. I think we can leave PHP for next week because it goes better with, I think it needs a slightly larger input than I can give it right now. Okay, any questions on JavaScript? No? No? Too much. Okay, great. So what we'll do is we'll see you up in the, so we're week 3 now for the, is it week 3, week 4? Because we had 1 week where we did the Clark Web Practical. So you're either carrying on with just your HTML, your CSS, or you're starting actually to program in JavaScript with the third one. Now I won't just say anything. I'll give up. I'll talk about the assignment next week, I think. That's what I'll do. Okay, so I'll see you up in the lab in about